Yeah, welcome. This is the Spring Data Community Roundup session. Who of you has been in the repositories talk we had yesterday? Okay, but not too many. Maybe a third of you. The idea of this talk is to give you an overview of, because in the other talks we usually show the JPA modules, because it's the one that most developers can relate to. I have invited 4 people, or 4 to some degree project leads of community-led modules. Peter is a tiny exception to that because we developed the MongoDB module ourselves, but he's in contact with the MongoDB community quite a bit. And he will start introducing you to the MongoDB module in like 15 to 20 minutes. Then we have Michael Nitschinger from Couchbase. He's the project lead of the project, followed by Costin and Christoph. I go into the details of those stores as well. So you get a quick overview of, okay, how does the Spring Data support for that store actually looks like, and I don't want to waste too much time of that. Do we actually have a microphone for Peter?
Worst case, I can take yours, or I take this.
Yeah, okay. I thought there should be a second one. Who's taking that? Was it taken away from us? Anyway, okay. We'll have that set up quickly. And then it's your turn, Peter.
Thank you very much.
Turn it on. Does it work?
Testing, testing one, I'm
Perfect.
live.
Thanks.
Okay. Great. So what I want to talk about is the Spring Data MongoDB piece. As you know, Spring Data allows you to connect to a bunch of different NoSQL stores with the same kind of programming model that you're used to working with relational data stores, but then to take advantage of the specific features that each store gives you. So I want to take just a couple of minutes of the time to talk a little bit about MongoDB and why you might be using that. My background and connection to this is I'm a MongoDB master, so I'm kind of one of the community evangelists, although I'm not an employee or directly involved with 10gen. So actually, just out of interest, who's already using MongoDB for some projects or has played with it? Okay, so some decent coverage here, which is great. And we know this is all kind of part of this whole NoSQL movement, which is saying, hey, SQL is great, relational algebra is really powerful, but it's not everything we want to do. There's some stuff that doesn't need fully ACID-compliant transactions, and yet needs more than just being stuck in a log file and being able to grep through it. So that's where we have this kind of whole NoSQL movement, into which Mongo as a document data store fits. The reason that I find people specifically choosing Mongo for certain projects, one thing sometimes is because it's schemaless. It gives you a couple of fairly distinct benefits. The first is if you're working with semi-structured data. Anyone had that? Imagine you're trying to build this application where you want to persist all of the information for Walmart. Start to think about that options table, right? What are all the potential options for any given product sold by a Walmart? They're so different that you end up kind of hacking relational algebra with this kind of option description, option value table that you join everything to make things work. Because to create a schema which has a property in a table for every possible option for those different disparate products wouldn't really make sense. So of course in MongoDB you don't have to worry about that because it's schemaless. If you've got some users that have just a first name and last name and you decide you want a social security number for a user, you just add that to a given document. So you don't have to worry about creating, changing an update to a schema or managing a schema with every possible property, which also has the benefit that you don't have to worry about schema migrations, which if you've ever tried to do that with tens of millions of records, can become problematic in a production environment. Then there's this kind of whole idea of a document model in general, which sometimes it can reduce the number of queries per page because you can have this kind of aggregate that has all the information you want to display on a particular page or a particular screen. And it simplifies the modeling for certain classes of domains. Some of the other reasons I find people using Mongo, it's really performant, even just in a single node. Even if you just got one node, the way that it's designed is to allow you to get a lot of query power out of that single server. And yet it's very, very easy to scale. You can get your high availability and scale your read load through replica sets. And that's very easy to spin up. And then if you want to scale write load, if you've got so much write hitting a master on a replica set that you need to scale that, you can scale that using auto sharding fairly easily. And what I really like about this is it's very manageable to get started with. I mean, theoretically, you can scale relational databases, and you can have master-master and master-slave replication. But if you've ever actually tried to do that in production yourself, it's a non-trivial undertaking. Whereas here, it's pretty much just spinning up a few new nodes and telling them about each other. And yet, at the other end of the spectrum, it's also really easy to get started with. There's a company I know in New York called Startup Giraffe. They're a Rails shop, but they build everything using Mongo. If they're like setting up a minimum viable product that's only ever going to have probably a few thousand users, they'll still throw it out in Mongo because they find it more useful for them to have a consistent programming model and to have something that will be scalable for high read and write loads easily if they need that for the clients that go there. So it's so quick and easy to set up. I was playing with Cassandra the other day, and I still find that it takes a while, especially as a developer rather than kind of a DBA, to get Cassandra kind of set up and configured and working. With Mongo, you kind of download it, set a couple of settings, and you're ready to go. It's also kind of cool that it's SQL without the joins, so that when you look at the programming model you're dealing with, rather than being like, hey, I've got to learn how to write map reducers, it's really straightforward to get started with queries in Mongo, because you're doing things like, okay, so I've got a repository here called database, got a collection of users, and I just want to return all the users. Or I want to return all the users with a last name of Smith. The concrete syntax is JSON, but the basic idea, it's kind of sort of SQL-y, right? I can say, and I want to select the social security number, sort by last name, and I've even got skip and limit. So if I'm doing pagination and things like that, it's a really good fit. So that was a couple of minutes talking about MongoDB itself and the kinds of use cases and the kinds of reasons that I find people picking it. How does that relate to Spring Data? Well, the whole goal of Spring Data is to allow you to use these kind of newer, I used to say new non-relational databases, but I don't think they're new anymore. But it's to allow you to use these newer non-relational NoSQL data stores with a programming model that's kind of familiar to you. Just out of interest, who here is actually using Spring and some of the Spring code for persisting to your relational databases? I mean, is that pretty much everyone in the house? Close enough. So what you get with Spring Data is effectively like you've got object relational mappers, you know, if you're describing like JPA or if you're using Hibernate for a specific instance of that. With Spring Data, it gives you not an object relational mapper, but in the case of Mongo, an object document mapper. Something so that rather than you having to think about the internals and exactly how Mongo works, you can just annotate your POJOs and give them the ability to persist and then access those fairly easily. And in terms of getting started, there's not all that much you need to do. You're going to describe the dependency for, in this case, this is the 1.3.1 release, which is the very latest version of the project. And then you can get a Spring to automatically create a proxy for the interface. This is using Java config. I'm seeing more people moving to the Java config rather than the XML these days for configuring things. And what this does is this sets up a connection to a local MongoDB instance, and it enables the detection of Spring data repositories. So this is going to get you set up so you've got a repository to work with. And then if you wanted to actually interact with it, here's a little bit of example code where we're going to take that repository, and then we're just going to, there's a number of methods available to you to delete all, or to create a new person and to set properties, and repository.save that person. So it's a fairly straightforward process now for interacting and working with a repository. And then in terms of the domain objects themselves, you see we've got a couple of annotations here. You describe, oh, this is @document. So we're going to be persisting this using the MongoDB, using the ODM, the object document mapper, and you describe what the ID field is going to be for uniquely identifying, and then you'd put in your usual kind of boilerplate into your Java code. In terms of the project history, version 1.0 of the MongoDB part came out, I think, in September of 2011. Then it was 1.1 came out in May of 2012. Then there was 1.2, and 1.3 is the latest release. 1.3.1 is the very latest version, and that came out. It's available on the GitHub now. I think it was released 2 days ago, something like that. And what do we have here? So yeah, so this is the 1.3.x branch, and you can see that we've got the release 2 days ago. One of the biggest things that you get from the latest version of Spring Data MongoDB, and one of the things that I wanted to take a chunk of the time to talk about now, was access to a number of the new features in Mongo 2.2. And this is actually, there's one particular feature in that I want to talk about because it's really important. And that is we now have access to the aggregation framework. Now, this isn't going to change your experience when you're just creating a new user or updating them or deleting them. Even for simple queries, this isn't going to be important. But one of the traditional limitations or challenges with MongoDB was handling aggregate grouping style operations. And historically, there were 3 ways that you could deal with aggregates in MongoDB. Starting from the bottom up, if you just wanted to do a group or a distinct, that was fairly easy. There were specific commands for that, and they worked just fine. So if you wanted to do just a very simple aggregate, Mongo's always been a reasonable solution for that. But then there was this kind of, okay, so I've got this, this aggregate that I want to describe that's got a number of filters and distincts and group bys, and it's got all of these different things going on. So a single-purpose aggregate operation didn't make sense, and it wasn't performant, obviously, just to load the whole record set into memory and apply the transforms. So what would I do? Well, up until Mongo 2.2, the answer was use the kind of JavaScript-based MapReduce framework. And while that's always been kind of a possible solution, I don't know, has anyone here actually used the MapReduce framework in MongoDB? Okay, hey, there is one in the room. Awesome. It's not the easiest thing to use, especially if you don't happen to have a background working with MapReduces. But more importantly, it's not the most performant thing to use. Once you're dealing with non-trivial data sets, MapReduce was always kind of this weak spot in the armory. It was kind of like, MongoDB is great for all these things. Yeah, aggregates, well, you know, as long as you've got a single simple query, it's fine. If it's more complex, you may be in trouble. And so what the aggregate framework does, the aggregation functionality in 2.2, is it gives you this aggregation pipeline where you can describe a series of step-by-step transformations for your data. So this would be one example of doing just that. What I'm doing here is I'm taking some arbitrarily large set of data, and I'm saying, okay, so the first thing I want to do, and so we're taking the database, we're working with the orders collection, so db.orders, and this is the native JSON-like description in Mongo. We'll look at the Java code you'd write through Spring Data in a moment. But basically, we're saying, okay, we're going to do this match, which describes that the status field must be A, so it must be in a particular status. And then we're going to group and sum. So what it's allowing us to do then is describe a number of steps. So we're only going to take the orders in the Asia-Pacific region, and then we want to group those by the country that they're in and sum up the total revenues. It would be these kind of classic reporting style queries that you might want to do with your data can now be described in a very kind of simple and intuitive way. And what's nice with Spring Data is it provides access to that now without having to kind of drop down and write a bunch of JSON-y looking stuff. So what we could do here is, in the general terms, and these slides will be available afterwards if you have to squint a little bit, apologies, is the only downside with Java, it's kind of hard to fit on a screen. It's a little verbose sometimes. So basically what we're doing is we're describing a new aggregation here, and then we're just basically passing in a comma-delimited list of the specific operations that we want to perform. So this is kind of the generic concept, and if we're to be explicit about this, here are some of the operations supported. One thing you do want to look out for, I haven't kind of compared this line by line with the 2.2 features. It supports many of the features in the aggregation framework, but not every single one. So if you're looking to use this for a project, take a little bit of time to go through the 131 documentation and to check what aggregate features it has and to make sure that it has all the aggregation capabilities that you need. And then if you were to run a specific aggregation, it might look something like this. So let's imagine, so in this case, we're taking this project tags, we're going to unwind, group, and count as n. You can give kind of aliases to things so that they are available later in the pipeline. And then this is basically allowing us to sort by the count of tags. So this is basically going to give us a certain set of tags and the ordering them by popularity. Or this would be another example where, let's say, we've got some zip information, a city and zip to state information. We could write, and I'm not actually going to go through this line by line, but it's showing the kind of comprehensiveness and the kind of complexity that we can support. But basically, you can create these arbitrarily complex aggregation pipelines that will take your record set and apply a set of transformations to provide you with the output that you want. Ended up running through just a minute or two short, which is better than a minute or two long. But what I would recommend is, if for any reason you haven't played with Mongo, I'd thoroughly recommend downloading a copy and just playing with it. I find it's a really interesting data store to work with. And then definitely check out Spring Data MongoDB release 131. And that'll give you access not only to the basic object document mapping functionality, but also the ability to do things like these aggregate queries. Hope that was a useful introduction. Let me get unset up here so that we can pass it on to the next person. And if you have any questions while I'm doing that, feel free to just shout them out quickly.
Next guy is Michael Nitschinger, leading from Couchbase, leading the Couchbase module. And yeah, just go ahead, Michael.
Thanks, Oliver. Can everybody hear me? Yeah, great. So let's do a quick show of hands. Is everybody awake already? Everybody had coffee? Great. So who has heard about Couchbase before? Who knows that it's not CouchDB? Okay, there was some confusion in the past with the name. Great. So, and one last quick show of hands. Who is having a separate cache infrastructure from the main database infrastructure? Great. Okay. So because that's one of the main aspects of Couchbase. So I want to split this 20 minutes up into two parts. The first 10 minutes, I'm going to give you a very quick introduction to Couchbase, what Couchbase is, and what its characteristics are. And the other 10 minutes, I want to spend hands-on on a demo and show you how you can use the Spring Data Couchbase module in practice. So Couchbase Server focuses on 4 principles, basically, where we architect all of our technology around it. The first one is easy scalability. So we want to make it very, very easy for you to scale from 1 to 50 to 100 nodes in a cluster, handling millions of operations per second. And we mean that literally. So you can start up with a 3-node Couchbase cluster, and you can add nodes on the fly to the cluster without a single second of downtime. We have a lot of customers doing it all the time, and you can not only upgrade your cluster, you can also downgrade it. This is especially interesting in cloud infrastructures, where you may have spikes of load, where you want to have more nodes in the cluster, and you want to scale it maybe down to be more cost effective in this case. The other thing is high performance, and I really want to emphasize the consistent high performance. We did a lot of architectural decisions inside our Couchbase server to make sure you get consistent high performance. So what does it mean? That we, even at a very high load, millions of operations per second, you can be sure with a good network and reasonable hardware, not very big machines, you get response times in the microsecond range. So we expect 300 to 400 or 500 microseconds of our primary key-based operations. And this is very important because a lot of our customers are using this as their main cache infrastructure. And with our 2.0 release, we moved basically from a cache, so from a persistent distributed cache, into the document database area. So you get a lot of characteristics that you find in caches, but with querying functionality that you find in document-oriented databases, which is really appealing. The third one is always on 24/7. So I already told you about you can add and remove nodes on the fly, and this is also true for upgrades. So what you can do is, let's say you're on the 1.8 release and you want to upgrade to 2.0 or 2.1, you can add 2.0 nodes and remove the 1.8 nodes on the fly without a single minute of downtime. So you can do upgrades. We have very, very good failover characteristics. So this is all very, very trimmed towards keeping you up 24/7 and keeping up with every kind of load that you get on your database tier and caching tier. And the fourth point is that we don't restrict it to a specific data type that you store. So in a relational database, you're storing tables and rows. In MongoDB, it has to be BSON data. And the short answer is we don't care what you store. So we are, who of you is familiar with memcached? Yeah, so one of the core pieces of Couchbase is a memcached infrastructure, basically, which is extended. So we are memcached binary protocol compliant. And what this also means is that you can store everything in there. So you can take a binary blob, a serialized Java object, HTML chunk, and just stick it in the database, and we will keep it for you and manage it for you. But if you happen to store JSON data, you can also do very, very advanced MapReduce style querying on top of your JSON data, which also scales out on the whole cluster. So if another node, the whole MapReduce infrastructure, completely transparent to you, will also scale across all those nodes. So just to give you an idea of the use cases and people who are using Couchbase. So one of the main areas where Couchbase is really, really great is social gaming, using it as a session store, also with the 2.0 release as a content and metadata store, using it as a cache, and for ad targeting purposes. So Couchbase really shines where you need very fast access, you want to have a lot of state mutations in your database. All these kinds of operations are really, really fast, really, really good. So we have a lot of customers running us in a very large scale, millions of operations per second. So it's handling real world scale right now. It's not just a small database that you use for your hobby project. So to give you a quick idea of how one single Couchbase server works, and this is very important. If Peter mentioned MongoDB, when you want to add a replica, you need to use MongoS. You need to have special infrastructure in place to handle shards. We take care of this for you at all. So every node in a Couchbase cluster is completely the same. You install a Debian package, something like a Debian package, RPM, so you install it. And so you install the package, and with a single click from the user interface, you just add it to your cluster. We do the sharding for you. We use basically a hash-based sharding approach in the cluster, and we move those shards around the cluster when you rebalance the cluster to make it larger or smaller. So you just use the API, you say, store this document, retrieve this document, and we will do the sharding for you. You don't have to have special sharding things in place. You don't need to care about replication. You can say, oh, I have this bucket, which is basically a database, and say, I need one replica. And Couchbase will care of the replication for you, right? So what happens if we want to store a document inside the database? So let's say we have an application server like Tomcat, and we want to store a document. So we use a set command, for example, and what happens then is the document directly goes to the managed cache. And you can think of it as a memcached on steroids, kind of. So it's really, really fast, it's really, really powerful. Couchbase manages the cache level for you, and it will store it in the cache. And what happens then so that we can be so fast is that we do the disk write persistence. So Couchbase is a persistent cache, persistent database, so it's not only in RAM. We will write to disk asynchronously, and we will do the replication asynchronously. So we handle all of these tasks that potentially block in other databases or keep your performance down. We will handle that asynchronously for you. In your SDK, you have the possibility to say, okay, but please make sure the data is persisted to disk if I really wanted to take care that it's persisted to disk. But we give you the flexibility to choose this trade-off on your own. We don't say, okay, we always make sure this document has been persisted to disk before we give you success back. Because in a lot of use cases, you don't care. If you use it in a session, in a cache context, like with sessions or very small documents, where you really care about performance, you don't care about if it has been persisted. If it's gone, then it's gone, right? So But if you want that flexibility to say, okay, but then you want to make sure that it has been replicated or it has been persisted, you can do that optionally. We give you the flexibility to choose. So the document, once it starts managed cached, asynchronously, it gets put onto the replication queue to other nodes, 1, 2, or 3 replicas, you can define them, and onto the disk queue to make it persist. So if the node goes down, the data is still on disk, you can start it up again, it gets warmed up, and it gets served from cache again. Now, imagine we want to read a document. It's stored in the managed cache and on disk because we persisted it. And if we want to read it, the first possibility is that we store it from, we already have it in RAM, and we get it back to you as fast as we can. But a lot of customers or users of Couchbase have the use case that they have what we call disk greater than memory scenario. So they have a huge data set, but they only need a fraction of it in RAM. For example, think of a social game, but you only have a fraction of all your registered users playing at the same time. It doesn't make sense to keep all of this data in RAM all the time because RAM is much more expensive than disk. We take care of that for you. So we will try to stick as much as we can into RAM as long as there is enough RAM available. But once you have more data than you are able to store in RAM in your cluster, we will evict it from RAM, but it's still persisted on disk. Once you access it, we will propagate it back to the RAM layer. So thinking about it from an operation perspective. So let's say you have 2 application servers, and in your application server you use an SDK. So we provide SDKs for Java, PHP, Python, Node.js, C, all of these popular languages, we have you covered. So imagine we have 3 servers, and all of the documents that you store inside the cluster get automatically sharded onto those nodes. So you can be sure that one document is active on one node all the time. So we can guarantee you in one cluster very strong consistency. So if you think about the CAP theorem, we are kind of a CP system. So different, let's say, to Cassandra, we really care about consistency, trading off availability. We have some features in our SDKs that you can use if you really need availability. What you can, for example, do is you can read from a replica node if the master happens to be down before the failover happens. So you can tune these kind of behaviors, but in a very, very strict sense, we are a CP manner. Okay, so we are a strongly consistent system. We replicate the data to the replica nodes, and also very important is, for you as an application developer, you don't need to care about where these documents are located. So you don't care about sharding, we do all that for you. The SDKs keep basically a cluster map. They know where all these documents in the cluster live based on a sharding algorithm. And also when you add and remove nodes, you never need to restart the application server. There's a streaming connection where those Couchbase clients are connected to the cluster. And once you add a new node, basically over the streaming connection, they get the new bucket map, and they know where all these new documents are located and just instantly access it. So you never need to restart your application server when you shrink or extend your database tier. Yes? So the question is how many copies of the document we maintain. That's easy to answer. One for the active basically, and then one for each replica to define. So if let's say you have defined for your database what we call a bucket, one replica, you will have 2 copies, one on the active node and one on the replica. And if it's always accessed on the active node, but if the active node is down and is failover, the replica is promoted to active and will be accessed from there. Yes? Okay, we need to distinguish between inter and intra-clusters replication. We provide a feature called cross-data center replication, where you can replicate your data between data centers. But in this case, one cluster is meant to be run in one data center because of the performance characteristics. We provide cross-data center replication as well, but it has some different characteristics because over a worldwide network, unreliable network, you have to have much different characteristics than you would have in a local data center. Make sense? Okay. So let me quickly move forward so I can show you some code as well. if we add a node to the cluster, what happens is what we call a rebalance process. The documents get moved in the background over to the new nodes, and once they're moved over, the client gets aware of that and can access it from over there. The cluster map on the node on the application servers gets updated, and the documents get accessed from this case, from this machine. What happens if you fail over a node? Let's say we have server 3, our SDKs access documents from server 3, but someone pulls out the power plug and the node goes down. During this phase, those documents are not accessible, kind of. This is a characteristic of a strongly consistent system, because if we were a AP system, we would say, okay, just put it somewhere else. But we really care about consistency. What you can do is you can read the documents from the replica node, but we don't allow you to write them. That would go to that shard. We have automatic failover characteristics to keep this time low. But I won't go into detail about that. If you have questions about failover and how we handle these scenarios, talk to me later. So with that, very quick overview to Couchbase. Any questions about the architecture before I move on? Okay. So basically, Spring Data Couchbase is what the module is the same for let's say, Spring Data MongoDB. We really try to take the Spring Data philosophy and bring it on top of the Couchbase model. So we provide templates, we provide repository implementations, and that's the main difference. We also provide cacheable annotation implementation. So what you can do is you can use a Couchbase cluster as a main document store and store JSON and query it in various manners, but also at the same time use it as a cache and throw any kind of HTML binary blobs into your system, which is really, really powerful. You can consolidate your architecture if you want to, but you're not required to. You can use this as a cache, you can use this as a document database, or even both. So with that, let's do a quick demo and show you how to use it from an IDE. So I prepared 3 examples here. Let's start with the template first. So I'm going to show you an application config, which is also very similar to the one that we've seen previously, intentionally, with MongoDB. So we have an application config that here extends the abstract Couchbase configuration. Let's do that. Can you read it in the back? It's a little bit. Okay, then maybe that's better. So we have an abstract Couchbase configuration, and the only thing you need to give us is basically an instance of the Couchbase client, which is the Couchbase SDK. That's all you need to configure for templates. And once that is in place, I have a small script here where we just instantiate our Spring application context based out of the Java config, and we retrieve the template bean. And on this bean, which is named Couchbase operations, but it's basically the template interface, we have all of those operations that you are used to. So you can say insert, you can say save, remove, update, delete. So you can use your CRUD operations very, very easily. And the main difference here is you can create your POJOs, you annotate them, so here we have a blog post, which is just a plain POJO, but it has an ID property, which is the primary key that we will use in Couchbase. Here we just created a static one. And what Spring Data Couchbase does for you especially is it handles all these translation to JSON, handles the mapping, all this kind of behavior that you would have to do on your own anyway is handled for is handled inside Spring Data Couchbase. So moving forward quickly, because I think we have 4 minutes left. Looking at repositories, if you want to use the repository feature, you use the same application config. You just say enable Couchbase repositories, give it the path, and here we define our repository, which is a blog post repository. And then in our code, you can use the repository methods. You can say delete, find all, find one, count. So you get all of these CRUD operation behavior out of the box. And finally, I want to quickly show you the caching use case. So let's imagine, let's see how we configure it. So it's the same abstract Couchbase configuration, and in addition to that, we configure cache manager. This is required in all Spring. Every time you use cacheable annotations in Spring, you instantiate a cache manager. We implement the Couchbase cache manager here, and it handles all of the storing for you. So let's say we have a class which does arbitrary complex computations. Here, we just sleep, basically, just to do something that takes some time. And we return some data. So you can see there is no reference to Couchbase at all. The only thing mentioned in Couchbase is the name of the cache, but you can name it whatever you want to. And in our code, if we run this, the long-running task here would be executed once, and it will take two seconds to execute because it sleeps for 2 seconds. But for the next 19 iterations here in this loop, it will go directly into Couchbase, fetch the data out of it, and give it back to you instantly. So let me go back. Let me go to the browser quickly. Yeah, and one thing I wanted to show you here, if you're not familiar with Couchbase, is we have an awesome user interface. And this is different to a lot of databases. This interface is your user interface to the whole cluster. We provide REST APIs, and we provide real-time statistics. So we have graphs, a lot of graphs that you can inspect, which is really, really nice for operation people. And let me just run this code here. And we basically benchmark the time it takes to execute. Oh, that's the wrong one, sorry. So you can see it takes only 38 milliseconds to actually retrieve the value. And if we go back to the UI, we can see the real-time stats. So we had a 20 iteration loop, and we can see that we had 20 operations per second. So it's very, very transparently storing your data inside the cluster, retrieving it out. You don't need to care about that at all, which is very, very powerful. So before Oliver is shutting me up, let me quickly get back to the slides, because I want to mention something very, very important for you, I hope. So, who of you is from the Bay Area or lives around here? Oh, not so many people. Who is in San Francisco tomorrow? Okay. We have a Couchbase conference tomorrow in downtown San Francisco, and I have very, very good discount codes for you. So if you want to go to the conference tomorrow, hit me up later, and I'll basically get you there for free. Okay. So we have very, very cool announcements tomorrow that I can't share with you right now, but it's huge. We have customers talking from PayPal, Orbitz, Nielsen, very, very large companies running at a high scale Couchbase. So if you're interested, I would highly recommend you to check it out. I'll be there tomorrow, of course. So thanks so much for listening, and I'll
hand over to Costin.
To Costin. Thanks, guys.
Thanks, Michael. The caching support is actually quite an awesome segue into the next speaker, because Costin originally authored the caching support in the Spring framework. He's unfortunately not working for Spring Source anymore, but at Elasticsearch, and he's going to tell you a bit about the Spring Data Elasticsearch project. Something Michael forgot is that we have a milestone 1 release of Spring Data Couchbase as of today, I think. That's it?
Yeah, thanks to Oliver, he released it today. So the first milestone release is available from the Spring Source milestone repository. You can grab it from there. We really, really would like to get your feedback on it to improve it even further and move it towards a stable release. The other thing I want to point out, Couchbase has native support for Elasticsearch. So every data you can store inside a cluster could be moved over to an Elasticsearch cluster transparently, so you don't need to care about that. In combination with Spring Data Elasticsearch, that may be a really, really nice use case. So you get the same API to your high-performance Couchbase cluster and perform full-text search on top of your data, okay? So, thanks.
Just hand it over to Costin then.
All right, so I'll try to be quite fast, because apparently I forgot my adapter, And this is quite an old laptop running Windows XP. So as you can see, I'm being quite extreme here. So this will definitely going to be aligning. So Spring Data Elasticsearch. Thanks for the introduction. My name is Costin Leau, working on Elasticsearch. How many of you have attended my session yesterday on Elasticsearch? Okay, quite a few. How many of you have attended the keynote? All right. How many of you have attended Chris's session on Spring I/O? Do you know what that is, a new website? Okay. How many of you here have used GitHub? Okay. How many of you here have used Stack Overflow? Okay. Foursquares, anyone? Nobody uses Foursquares here? Come on, you can admit it. Well, I mean, if you used any of those sites, you're pretty, yes, there you go. If you use any of those sites, you're probably familiar with what Elasticsearch is. So, punchline, what is Elasticsearch? It's an open source search analytics engine. You can deal with any type of data, structure and unstructured. It's in real time, so most operations occur in milliseconds up to 1 second. Has some interesting things called analytics or facets, and it's REST-based. Designed for the cloud, it can scale out, scale in, and can deal with a lot of data. So, Elasticsearch. First of all, one of the thing that most people do with Elasticsearch tends to be quite flexible is doing search. Any type of search, any type of document, any type of infrastructure you have. So for example, Spring I/O, the newly announced website uses Elasticsearch internally to do all the search. And again, there is some interesting architecture there. It's going to be open source. You'll see there are some documents that are cached, some are on GitHub, some are in a different location, or some are even locally within Cloud Foundry. And all of that is being pulled together and made available through Elasticsearch. GitHub, right? I wanted actually to connect to the internet, but unfortunately we don't have one yet. GitHub uses Elasticsearch throughout the entire website for everything, any type of search that you do. So whether it's issues, code base, everything is there. Quite some big numbers there, around 20 terabytes, 1.3 billion, 130 billion lines of code. And again, this is stuff that it's growing. As you can probably tell, if you use GitHub, everything is in real time. You have some code, you start searching for it, it's already there. So there is no caching, no middle ground in between. Foursquares, I've mentioned that as well. And before going to Spring Data Elasticsearch, just wanted to give you a quick look at how things are. This is just a console. I have here Elasticsearch running. Here are just some scripts so you can see how adding data to it is pretty basic. I'm using curl. I'm adding in some data. Pretty basic, just JSON structure. That's about it, right? I don't have to define any schema. I don't have to define anything. But to make things a bit more interesting, especially since it's a lightning talk, what I did was take Stack Overflow, because I was assuming maybe I don't have enough connectivity here. So I took the Stack Overflow dump. They dump all the data within an XML format, put it into Elasticsearch on my machine, so yay. And now, you can do all sort of queries against it. So you can do things like find me all the questions within, well, not Stack Overflow, but programmers stackexchange.com, because Stack Overflow tends to be quite big. And look for all the questions which contain Spring Framework. And this is how it looks like. I haven't defined any mapping. I just shoved in the JSON into Elasticsearch. I'm now doing a multi-match, so I can do, I can run the query, and you can see how it looks like. I have a couple of things here. This is the raw JSON that is being returned to you. So you can see index, type, score, the document itself. And we also have this nice, it's called Elasticsearch, just a script. So we can actually parse the JSON, so we can give these nice printouts. So when we're doing the demo in the console, you can actually see the how the results are looking at. So you can see, okay, this is a question, has a title, why not Spring Framework? This is a body, and here we have some arguments around it, and we have returned the first 10 questions. There are also a variety of things that you can do with the data, right? You can do creation per date, so you can filter it by date. You can do things like match it to the, do a bit of geolocation, even though in this case it's not real geolocation, is only look at the questions that mention Spring and Java since 2011, where the owner has declared to be within the States. You can limit the data that is being sent to you, right? You can do things like selecting only the fields here. So quite a lot of interesting stuff, but where a search engine really shines is when you actually can do more than the basic full text search. For example, you can do highlighting. So the best way of doing that is to just run a query, which is find me all the documents that mention Spring or Java, but also tell me where exactly in those documents Spring is or Java is. So here you can see the same results, but what's interesting is rather than returning the whole body, right, because this is a post, I can only have a fragment. So I can say, find me within that document the match and then highlight that for me. So in this case, we just use the console to highlight Java, but actually we get information within the JSON about that. So for example, if you look here, you can see that, by default, we say, okay, within the body, we found a fragment. We define it's up to 50 characters, and you can see Java there emphasized, right? So pretty cool stuff, but since analytics seems to be all the rage now, right? So this is just, again, basic data. I haven't done anything to it. I haven't prepared it. I'm just running queries against it. I can do, are you ready for this? Faceting. Wow. I've just done analytics in the command line. So what I did is just to give a bit of an explanation, right? This is the same query in JSON. So I did a search for Spring and Java, right, within the title and the body, especially in the title, from 2012. Did a bit of weighting here, custom scoring. So I said, find me all the posts, but then take the rating and then multiply that by the score. So I'm filtering them first by the ones that have the most posts in it or the most rating. Did a bit of things like filtering only the title, give me just the title, the owner location, creation, do a bit of highlighting, which I just showed you before, and do some faceting, this stuff here. So what I'm literally saying is, as the data comes in, first of all, look at terms. Terms is a list. This is actually the structure that Stack Overflow has. So each post has certain tags like Java, right, web applications, Spring, and all of that. So I'm saying get that information in. So as the data comes in, I'm running the query. I'm then slicing and dicing stuff. So I'm saying look at all the terms and then group them based on the terms. I can also run a facet which is called frequency, which in statistical term would be called histogram, which means look at the data set, identify a field which is of a type time, and then slice it in this case per month. And I'm also doing some interesting things here, which is statistics. So I'm saying look at the answer count, do a count on that, and then show me the standard deviation. So what we did here in the tool is we just ran the query, right? So it's the same query as before, but with the facets, we could, for example, slice it per tag. So you can say, okay, so from all the results, right? This is not something that is done before. You run the query, and then as the result came in, we can look at it. We can say, okay, there are so many tags in Java, so many in C++, learning C, and then you can also have the frequency there, which is a histogram where we basically slice and dice the data based on the month. And probably some of you are wondering, well, where is the statistics? Where is the standard deviation? Well, we tried hard to actually make that happen within the console. It doesn't really work that way. Apparently, we don't have enough resolution. So you can see here sort of how this thing looks like. You can see that from all the results that we get, we have posts with 0 comments. Some are 27. The mean is 3.00, and we have a standard deviation. So the console is cool and everything is lead or Haxor, but actually you can have something like this. This is just a UI. It's entirely written in JavaScript. It's called Kibana. You can download it. You can play with it. And it works against Elasticsearch. And I can do a bunch of stuff here. Everything is in real time. And the same facets that you've seen before, they are here. So this is a histogram. I can zoom out on the data. Here I have the comments, and this is just a graphical representation of the tags. Now, the nice thing about the whole thing here is everything is JavaScript. And actually, if you look at it, this is just a JavaScript UI that whenever you run a query actually turns up to this REST command, right? So if I'm looking here, how can I generate this histogram? I have an inspector. You can see the curl, and then you can actually see the JSON command or REST command that is passed to Elasticsearch. The same thing here with tags. So literally, I'm running the facets, and then this stuff, the results are being pulled in within the UI within JavaScript, and then are being rendered. And again, everything here is entirely dynamic because all the logic here is executed within Elasticsearch. So whenever you run something here, the queries are being run in real time against the Stack Overflow, which is sitting in Elasticsearch, so it's all being streamed in. And in this case, the UI, which is JavaScript, does this stuff. So I can, search it. I can zoom in, several options, and I can say, you know what, I want to do multi-query, so I can say PHP, Ruby. All right, I can say, okay, let's add some Python in. Let's add some Spring in. Okay. All right, and the whole thing works automatically, and the beauty of it is this is just a UI. So this is just JavaScript, right? It's entirely up to you. There is no logic here. This is not a built-in system. All it does is, okay, I'm taking your command, running the query, creating the JSON for it, querying Elasticsearch, and getting all the data in. So you have a mixture of search. Okay, I'm looking at some data, and then you're looking at a bit of analytics, such as slicing and dicing, what we call facets or aggregations, to return the data in. So, I can go as crazy as possible, and again, because everything is real time, I can very easily drill in and drill out. So there are also some interesting things here. For example, you can save this dashboard. It looks something like this. So it's just JSON. You can even put it in Elasticsearch, and you can just share it through Git. This is something that we do. So that would be Elasticsearch at a quick glance. There is Spring Data support for Elasticsearch. Just to make sure, this is not something that Elasticsearch, the company, authored. This is actually something that was contributed by the community, some guys from a company called Biomed Central. We're trying to help them out. But it's just another, I think, good example of how happy we are and how grateful we are for the community around Elasticsearch, because there are a lot of cool stuff, a lot of cool projects where people actually contribute things around Elasticsearch is still being open. So they are the main authors here for Spring Data Elasticsearch. So if you like that, they are the one that you have to thank. I'm just here to sort of give you a slow walkthrough, a quick slow through it, and show you what you have. So it's on part of Spring Data projects, which we're quite happy about. Under Spring Source now, it's actually Spring projects, and you can find what this is a nice thing about Spring Data in general, in that once you understand the concept, you basically just move between implementations. So ease of configuration, right? Ease of use, templating, repository support, querying support like Query DSL, all of that is now available for Elasticsearch. So this is just, I'm not sure whether you're familiar with this. On GitHub, we have this wiki where you can see this sort of the features of each project. And you can see right there, Spring Data Elasticsearch. You can see that we have mapping, the subsystem templating API, Spring XML, and in terms of repository support, pretty much everything. So we're quite there. The project is fairly young, has around 6 months, more or less, and we're the project is going towards the initial M1, and hopefully after that GA. We have tons of coverage there. You have also an example so we can play with it. Just to quickly show you through it. I'm not sure exactly how much time I have. Okay. So we have configuration support. You can have both XML and Java configuration. Quite common. This is useful for connecting to a cluster, especially when you have a cluster where the cluster can be dynamic. You can specify multiple IPs or only one IP. You can mix and match, so you can go to just use Java configuration if you want. You can use XML, or you can mix and match again. That's entirely up to you. Regarding templating, we have quite a number of options there. So you have a template that allows you to create, index data, to do mapping. As I mentioned, more of the data can be pushed in and is being mapped automatically, but in case that you want to tweak, want to adjust the mapping, you can do that as well. Tons of querying support. There are about 3, or actually there are 5 types of queries. As you probably imagine, you can do structured search, you can do unstructured search, and then you can do custom scoring. So structured search would be, unstructured search would be you just doing, for example, full text search. You have a lot of data, you're just looking for the documents, you're literally looking for patterns, in this case text. You don't really care how the data is formed, but rather you just want to know whether something resembles what you have. Structured search is a bit different in that you actually bring down the data that you're looking at in some type of types. So then you might have, okay, I have a document where I have a title. So now I have a field called title, I have a body, I have the title, right, can be a short sentence. I have, as you've seen in Stack Overflow, I have an author, which has a location. So now suddenly I have an object that actually has nested fields, and I have a creation date. So now I have a field that has a certain type of date. You can do things like geolocation. So now actually I have a string that actually is a hashtag or geohash. So now you're looking at not just patterns, but actually you're looking at things that have a structure. If that document I'm looking at doesn't have the structure, right, I don't care about it. So this is where you have more like structure search. So your question is whether there is a Spring project on top of Spring Data? Oh yeah, R. Okay. So currently we don't have one for R. I'm not sure whether we're going to have one for R. R is not really. So R is a querying language, I would say, more or an analytics tool rather than a storage. So I'm trying to answer this. If you look here at the possible features, it wouldn't make sense to have repository support over R because R is not a storage. R runs on something else. It's about querying. Right, querying analytics. But at that point is how do you interact with it? I mean, I assume you could do some improvements to say I easily run the R script, but beyond that, I mean, I'm not that familiar with R. It's just that in general, Spring Data is about data, and data means storage and all that, so SQL, no SQL. R is a separate discussion. The similarity is that you can do querying over data, but this is where it all ends. So I don't know, I guess Oliver can talk about whether there are plans about a Spring R.
So there's no concrete plans for a module right now, but we've discussed it internally, so we're looking into, okay, what could maybe fit into this querying repository model. So just come back to me and after the talk, and I can direct you to that guy looking into it.
Yeah, so you know, I guess you could say that, and I'll come back to faceting in just a bit. In terms of Elasticsearch, there are multiple aspects to it, right? There is the search engine where you have the data in, and then you start looking at things, and then you have the analytics part. Now, we like to think of them as being very well connected, in that because we store the data and because we have looked at your data, we have a lot of insight into what's going on. So doing aggregations on top of it actually makes, you know, full sense because we already have that information available. So it's just something that we do, and it scales really nicely because it's a distributed system. So the more data you throw at it, the more information we have, and then the more computational power we have, so we can return the information in. So R is more about, I mean, R is a full-blown language tool to doing analytics. Elasticsearch helps. You could, but what I'm trying to say, where I'm trying to get here is that you have building blocks within Elasticsearch, but you don't have a full-blown language. We support things like scripting, so you can have your own code literally ran, whether when you add data or when you return data, as I've shown before. But you know, we're not focused on providing an R replacement. And you know, if you look throughout the various use cases where Elasticsearch is used, we're an engine, and we think we're quite flexible. So you can do a lot of things with the data. We're not chasing, you know, just analytics. We don't want to be, again, just R. We don't want to be just logging. We think we can actually work with all of them, but we try to be generic. If there are certain implementations or certain tweaks of the engine towards a certain domain, then we're more than happy to support that. Yeah. Yeah. Oops. Right, but that's, I mean, I don't want to spend more time on this. Still, I'm not sure exactly how much time do I have. That would be good to know.
Yeah, it's fine, but let's just keep it offline, right? That we just get...
Yeah, I guess what I'm trying to say is, and break this down, is if you look from the abstraction point of view, you can abstract a lot of things. You can say, okay, a SQL, R, all that, they are the same. The problem is the devil is in the details. So actually, there are quite a big differences. If you try hard enough, you can actually, push a square through a cog. That works. But I mean, you can have a SQL-like implementation over R, which works on top of Hadoop, which works on top of a relational database. Sure, that works. Is it really useful? I don't really know. So my point here is, sometimes it makes sense to have abstractions, but sometimes it doesn't, especially when you're looking at larger volumes, because abstraction loses a lot of context. You have to abstract things away. So R is pretty mature. It has a lot of libraries. It's very Python-based, and within the statistic environment, it's a great tool. Whether that makes sense for doing analytics throughout the entire data set, I don't know. There are probably a lot of mathematics involved, and maybe there are some similarities, but at the end of the day, you still have R and something else. So going back to sort of the Spring Data support, in terms of querying, I guess this is where we took off. Right, I was mentioning structured search, unstructured search, and then custom scoring. Custom scoring tends to be something that a lot of people actually want to use. For example, when you've seen look through a post and then you do it based on rating, you're actually, what you're doing there is you're sorting data, and then as the data comes in, you want to add some weight to it. So you can say, for example, well, you know what, I'm just going to show you, this is better. So if you look at custom score, right, what I'm doing here, I'm doing a search, and I'm looking for all, doing a multi-match, so I'm looking, right now I'm doing a structured search. I'm saying, look at all the documents that do have two fields, one is body and one is title. What I'm doing here is called boosting, so as the data comes in, depending on what type of analysis I define that index to be, the document has a score. So that is, okay, you're interested in indexing words, and I see that a certain word, for example, appears more than a different word. So then when you do a query based on that, I can see that this document is more relevant to your particular query, to your particular question, than it would be in a different query. So what I'm doing here is boosting. So I'm saying run a query, and this is called Java, on two fields, body and title, but for the title, I'm more interested in that. So I'm literally doing boosting. This is already a bit of custom scoring or weighting, where right, I'm running a query and then I'm doing actually a difference. These are more relevant for my queries, even though both of them match that particular query. Right, doing filtering here, and this is an interesting bit. This is probably the most custom you can get. So what happens here, this is executing a script. A script is any type of JVM script. You can use Java itself, you can use Groovy, you can use whatever have you. So what we're doing here is we're running the query, and then as the results come in, and you can do this as well for when writing data, this is the case of reading, we execute a custom script that says, look at the data that you're retrieving. In this case, look at the document, get a rating, so this is a user-defined field, take the value and then multiply it by score. Underlying score is the score that I just mentioned, that I mentioned here in this context, which is done by the search engine. So when I'm saying do the query, you already have this notion of a score which is relevant, but also look at the user data. So look at the users, the rating that they had, and then bind that based on the score, because the score tells me that this post have more Java in it than the other scores in the title than in the body, right? So what I'm doing here is doing weighting. Another good example that I probably used before is when you're looking for restaurants. You're saying I want chopsticks. Chopsticks would be just a full text search. Everything that has chopsticks in it, I need a match. I need all the restaurants that are named chopsticks. At that point, I have a structured search. I'll look at data that has a restaurant, not in the menu, but within the title. And then I'm saying I want all the restaurants named chopsticks within 10 miles of me. I'm doing geolocation, adding a context to it. And then at the end of the day, saying, give me the ones that have the biggest review, right? This is when I'm adding weighting. So I'm moving from as unstructured to structured to custom scoring. So this is exactly what happens here. If you look at search custom score, you'll notice that they're actually sorted by rating. So I have, Java and Perl. Okay, I have rating at 12, pretty nice. This one, Java styles with a team rating of 11. So you can see that first I'm running a query, and then I'm solving the query based on the rating. So we try to support all of these queries, in different ways in Spring Data Elasticsearch. So you'll have criteria, which allows you to build the query itself. We have strings, so you can literally just pass in the URI or the query DSL. And we have what we call search. And this is useful when you want to do things like faceting. So because what happens there, we give you not just the result, but actually we give you a API where you can actually look at the result stream as being returned to you, and you can look at the facets. You'll see in just a second. Bulk operation, right, the usual suspects, and scrolling and streaming. Regarding repository support, frankly, I don't think there is much to say here except, this is repository implementation for Elasticsearch. And a lot of emphasis was put on the querying side, because for the most part, what we perceive Elasticsearch as being is a tool to allow you to explore data. So exploration means you have a lot of ways in which you can query your data. And we try to mimic that in Spring Data Elasticsearch as well. So I guess everybody here is familiar with repositories. We have the typical method support, where based on the method name that you specify, we can actually infer the actual query. We have quite a lot of support there, from basic Boolean operations to things like starting with, ending with, contains, before, after. So now we're looking at things like date. And what we're also looking at introducing is geolocation support. So for example, you can say, give me, find by name near, and then you can specify the location. And this is, a bit of mapping that happens there. I didn't mention because, again, it's obvious everybody within the data repository does it, such as how do I map objects in? We have support for mapping. We do this automatically. Elasticsearch does this as well. And you can also specify various mappings. Just a bit of code. Templating support, what you expect, right? You can do basic operation, delete the index, create the index, put mapping. An index is, well, just to I guess break it down, right? Each storage or each product under Git have their own terminology for various purposes. Elasticsearch underneath for the searching part, for some pieces of it uses Apache Lucene, and that's why a lot of terminology from Lucene is actually used within Elasticsearch. An index is just a namespace, if you can think of it. So in a relational database, you'd have what you call a database. So you connect to MySQL and say, connect to this database or that database, same with Oracle, right? That's a big namespace where you store data, you move to a different namespace. That's an index. And then within a database, you can select a table. If you would use something like, HBase, you would say move to this collection, right? So collection or table, they're the same. In this case, it would be a type. So we use in Elasticsearch the idea that you have an index, and on an index you have certain types. In Elasticsearch and in Spring Data Elasticsearch, we try to simplify that, so you don't think necessarily in terms of indexes and types. We try to mesh those together because we already know the object, so we already have a typeness within your domain. We already have a namespace, so you'll see that the syntax is a bit simplified, and that we don't necessarily make that distinction because it's already implied by the object that you're specifying, right? I'm creating an index, and within that index, I'm looking at the articles. So anyway, deleting the index, putting mapping, running a query, you have the typical builder, what you expect, and then you can actually index that. So you can actually send that to Elasticsearch, you say, look at this data, analyze it, break it down, so then I can run queries on top of it. Mapping support, for the most part, you probably don't need this. Elasticsearch is smart enough to figure stuff out, and actually what we do with Stack Overflow is just throw data at it. Because it can automatically figure it out. Your documents don't have to be the same. You can, under the same type on the same index, you can have documents, all of them be completely different. Some of them might have extra fields, some of them might have fields with different types. That's not a problem. Elasticsearch can automatically adapt to it. But if you want to have control over your mapping, typically that would happen because you have an object that is not entirely mapped to Elasticsearch. Then you have various options. And you can see there some of them. For example, you can have the class level, you can specify the document and specify indexing, things like that. For example, the first time I'm adding the document, I'm adding it into a location. How many shards there are, how many partitions, how many replication factors we have. Just to give you an example. Okay. Meaning what? 5 minutes, 3 minutes, 4 minutes. Okay. Just quickly. You said I should be okay. I just went wild with it. So Elasticsearch by default is, as we said from get-go, is distributed. This means the idea that you want to scale out is entirely there. So for example, if you look here, this is just a information about how the data looks like. You can see here the Stack Overflow, Kibana, this is the implementation. This is just a demo, just a bunch of stuff that I added. You can see there is split into 5 pieces. this doesn't have to do anything with the size. Rather, the data is partitioned automatically into pieces. And I have one node. All the data is here. This is our primaries, one copy, the master copy of the data, and the replicas here are the copies, which are currently unassigned. So if I'm looking here at the cluster health, I can see that, okay, cluster is yellow, meaning there's no data loss, but still, I wanted to make a copy, but I don't have any other node to put the copy in. So for example, now that I want to start another node, I'm starting the node, and if I look here at the cluster health, you can see that I'm going to move from unassigned, where I was in the yellow. I was in the yellow, meaning I have no data loss, to green, which means I don't have any data loss, but I've managed to satisfy the requirements. And the requirements were that out of the box, I need 5 shards, which is fine, but I also need to move them. I have one replica, one copy. So I've added the second node, and you can see that on the first node, I still have the primary, the master data, and then on the second node, I have all the replicas have migrated to that. And if you're curious how this looks like, this is just an endpoint, another REST point where I'm just querying. I got the JSON in. Give me the cluster state. I got the cluster state, and I'm just processing the JSON in. And now if I kill the node and my battery is dying, I cannot go in anymore. My laptop refuses to work. You can see that now I move to the initial state where I kill the node, right? The replicas are unassigned because I don't have any other node to put the copy, but I didn't have any data loss. And if I move here, to the cluster health, you can see that now I'm back in yellow. And if I'm going to kill the last node, probably I'm not going to have anything to work with, right? And it's full data loss. So this is about sharding, things like that. How many ways to slice and dice your data? You can do that dynamically in Elasticsearch. You can have through configuration, and you can do that to Spring Data, Elasticsearch when you add data in. So a lot of flexibility there in terms of mapping. Faceting, just want to mention that this stuff that you've seen here, right? These are queries and these are facets, right? I've showed you at the command line where you literally put within the query, and just to prove a point again, this UI here has this JSON underneath, right? The actual requests, facet, do a query, and then here story by terms, and then by fields, and the same support you get here within Spring Data Elasticsearch. So you can run the query. What we do here, we say run the query. Run a facet, in this case, look at the fields, date, and authors. And this is a terms facet, which means I'm looking at the terms, breaking it down, and then I can say, okay, give me the results, and then break it down per date and then per author. And again, you have support for that in Java as well through the client. That's it.
Awesome. What a run through. Thanks, Costin.
Thank you.
Yeah, up next is Christoph Strobl. He has something to celebrate, I think, today. Not only his overly long travel, but yeah, he's leading the Spring Data Solr project, and yeah, he's probably handing the surprise to you guys.
Just go on.
Shall I go in? Okay. So we released the GA version of Spring Data Solr yesterday alongside the Couchbase module. So there's a Spring Data Solr 1.0 GA release as of yesterday already. So, and Christoph will just give you an introduction to that module. Again, you all get this Spring Data book that covers, unfortunately, not all of the community modules yet, but the broad range of basic modules of Spring Data, so that you can play with it. Quite a lot of sample code. And yeah, we encourage you to just try out the community modules as well, because as you've probably already seen, it's quite easy to pick up a new store through the API. And yeah, now it's your turn, Christoph.
Okay, thank you, Oliver. So what you probably don't know, that it was one of your talks back in 2011 that actually inspired me to do the Solr module. You showed up at our local user group and presented stuff about Spring Data JPA. At that time, this was really great and inspiring talk. So since then, the project has evolved right now a little bit, and what I'm going to do is right now to show you, to give you guys first an impression of what Solr is, So this won't take too long, 2 or 3 minutes, so that you just see what is Solr about. Then we'll have a short look at the Solr template and repository support within Spring Data. And the final part, and I guess this will be the longer part, will include some demo code where I show you what you actually can do using Spring Data Solr within your application. So Apache Solr is an enterprise search server. It's built upon Lucene, has multiple interfaces, some REST-like API where you can get data out of Solr in various formats like JSON, XML. Here's a special format called Java bin using for the Solr J client. Solr supports multiple collections, so these are actually the cores where you store data in. You can think of it like a database table, somewhat. Solr is clusterable, and these are it has many, many more features like highlighting, faceting, and so on. I guess the mic has lost. It's okay, great. Yeah, many more features, so just to name a few. When we have a look at the Solr schema, which defines the data types within your core, you'll first recognize that there is a field definition. So Solr ships with kind of data types you have to use while indexing your data. So what you see there is a field type definition for a string field without any analyzers or tokenizers applied to it. So it would take the data you put in just as a single string. You can apply analyzers and tokenizers to your input data to tell Solr how to index and compute the data you put in. So what we got here is a keyword tokenizer factory, which actually doesn't really do much. It just says, just take the string as a whole fragment and don't split it up at any time. The filter we apply here is a lowercase filter factory, so what we got when we use this field type on an actual field, which would represent the property in our domain model, would be a lowered field where you got, so you just would have a lowered string in that field then. Great. There's one more thing I want to talk about when having a look at Solr. That's the way you query Solr normally. So it offers this HTTP interface, and you just put in those queries like that. So in this case, we would look for a document having Spring and data within the name field, and the document should be of type Solr. And there is pagination support as well. So we want to get the first 10 results out of the store. With SolrJ, we got a Java APIs for the HTTP request underneath. So you can see it's pretty much the same request string in both implementations, and there's not that much abstraction in there. And that is where Spring Data Solr comes into play, which ships with its own query API. So you can see you define a query for the name field having Spring and data in it of, and the type must be Solr, and you can use those page request objects you probably used to from the other modules to paginate through all the results. This leads me to the template and repository support. So from the Solr template, you can get access to all those very low-level functions Solr provides you. And for those of you who know Solr will recognize that this is very close to the SolrJ implementation. So basically, what we're doing here is we use the Solr template and create a new product with ID foo in there. We'll have to commit the new product to the index so that Solr is aware of it and can return it. We can get those things out of there just by using the criteria API. telling Solr to get to the ID field and request a document with ID foo and use the Solr template query for object method to get it out from there. There's one thing I want to mention about the transactions of Solr. So Solr handles transactions on server level, which means if you have multiple clients sending data to Solr and you commit on one client, you'll probably will commit all the transactions from other clients as well. So you have to be aware of that. The Solr repository support handles transactions for you. So if there's already a transaction ongoing, let's say you get a JPA data source inserting something into your database and you want this to be indexed within Solr, and the JPA transaction fails, the repository support will automatically roll back the changes for you within Solr. And to do the same thing we just did with the Solr template means creating a new product within the index is relatively easy using the repository support. Yeah, that's it. I guess we got a few minutes left, so let's start over the demo. I'll just start my Solr 4.4 distribution on my laptop. This is the default distribution, and it ships with an example, and I already loaded the example documents within the index. So as Solr is started right now, you can see we got 32 documents, so this is the amount the example ships within our index, and we can query those documents relatively easy. So this was a query for all documents, executed within 2 milliseconds and found 33 documents. To use the search for a string within the name field, we would just go on and start typing in here, so which would execute the query then. So right now we got 2 documents found. This will be a Canon power shot and some photo printer. So I don't work for Canon, don't worry. This is just the sample data that comes with Solr. Fine. So I already prepared a Spring MVC application, booting up via the Java config, and I enabled Spring Data web support for pagination and applied the Solr context, which basically starts up enables the Solr repository support, creates a new Solr server factory, which is a multi-core Solr server factory, so which we can use to create the Solr template, and we tell the Solr template to use the collection 1, as this is the default collection in the example application, as you can see here. So this would be collection 1. What the application will do is it will take the input data from a field, split it up by white space, and propagate it to the Solr repository via this product service, which will do basically a find by name in query against Solr. So there is no implementation. This is a Solr CRUD repository, so there's just the interface, and the implementation is backed by the Spring Data module. I guess the server should have started right now. So when I load this, you can see I did a query for all results. We got these 32 documents within the index. We got those pagination support, so out of Spring Data, which you can see there, please mind that the pages start at 0, so the second page would be at index 1. we can now go on and search for Canon as we did before and get those two results out of Solr. So what would be really nice here is if I could get some kind of suggestion. As a customer, I would love to know what's in the index while typing. So let's see how we can do this with the Spring Data Solr module. All we have to do is to basically open up the product repository and add a custom implementation for it. So I already prepared this one, which is the interface of the product repository custom, which has a single method returning a facet page. So we'll just use faceting as Costin already explained in the previous talk to explore data within Solr and present those results within the search box within a drop-down field. So, sorry. Let me just go into that for a second. Open implementation, please. No. Further. No. Where is it? So there is this product repository impl where we got the find by name starts with method doing a simple facet query on the name field of the entity. And we use the query for facet page operation to query this. So there's one more thing I think I got to do, which would be in the product service implementation. I have to call the method and alter the JSP file, so to put a little jQuery in there, which will do the JSON, which will do the HTTP request against the backend. Oh, time is almost up. Hurry on. So let's see, just reload this. Yeah. So let's see if it works. Yeah. So there we go. We got our suggest box based on the data within the index and can do this. So, but what really would be nice if I could get this a little bit easier, because there's all of this typing of custom repository implementations. So I'll just go on and remove the where is it? Product repository. Remove the custom implementation and add this one. So what I did is I just copied the method signature from the custom implementation over there and added the add facet annotation. I just got to rename the product repository implementation class a little bit, so to make sure it doesn't get picked up by Spring Data comments. So as there is some naming convention. Great. Republish. And if everything works out, this should still do the same thing. So let's see. Yeah, great. So you can do this all alone with the annotation. Two more things, if we got 5 minutes time, I would like to show you. Is it okay for everyone? Okay, just fine, then I'll just go on. The first thing is highlighting, which Costin already mentioned before. So you can do basically highlighting with Solr and the Spring Data Solr module by just adding add highlight, defining a prefix and a postfix. And this should then show up within the result. So, come on. Yeah, there you go. So I did the highlighting on all fields, so Canon would show up. I guess this is the company name, and this is the product name, and there we got some. Don't know where in which field this right now is, but you get the point. And the last thing I want to talk about is the custom document mapper that ships with Spring Data Solr. So one question: are there any Solr users right here? Okay, ever tried to put in your custom types within the beans you propagate to Solr? So using enumeration or inheritance? No, never tried? Good idea, because it doesn't work out of the box with Solr. So when we take a look at the product we are using within our model, you can see there is a location field, which is a geolocation using longitude and latitude, which is defined as a string, comma-separated string holding those values. This is not so nice, so what I'd like to do is to change this to geolocation. Yeah, just got to alter those settings. Sorry. And Spring Data will basically recognize that this is of type geolocation, will apply a custom converter, so you can hook in your own custom converters for your data types and will translate them correctly. I now got to alter the product view a little bit, because there is some code in there which will take the location data, as you can see here. So it would go for product, location, latitude, and longitude to display a Google Maps image. So I guess the server has already started again, and just reloading the page again. Great. So basically I'm sorry. Problems calling the function length, of course. Yeah, I forgot to comment out as it was a string before, you can clearly see here the map would have been displayed if the string with the location would be greater than 1, greater than 0. So I got to comment this out quickly. And reload the page. Yep, there we go. And there shows up the map with our custom type. Great. So, questions?
We're already using Nitschinger at this moment.
Yeah.
We already built a service layer on top of it. Is there any benefit to replace our current service layer with Solr?
That depends on the use case, I would say, because Solr, I don't know how you're using Lucene directly. So with Solr, you get an additional component within your infrastructure, and you have to take care of. It's a server basically offering you all those operations. So it really depends, I'd say.
Shall we go offline for that? Probably, if you want to discuss this in more detail. I'd like to thank the 4 guys presenting here. Thank you guys for attending the session. Yeah, if you definitely get the book. If you have further questions, because we're running late, the guys will be around today, and yeah, just catch them and ask questions as you want. Thanks for attending, and have fun at the rest of the conference. Thanks.